the player can take one of those envelopes and decide to keep it or to substitute by another one instead of the first one. So it seems that there is no problem because we don't know anything more about where is more money. So to take another or not, it's not clear. Does make sense or not? But in simplest consideration, suppose we take first envelope and it could contain some value A. Then the other envelope can have 2A or 1/2 of A with equal probability. So the expected value, as you see in that formula 1, is simply mean value, 2A and 0.5A, which is 1/25A. So it seems that the second envelope, mathematical expectation of amount in it is 25% more. So it makes sense to switch those envelopes and win on it. And of course, here is another side of the problem, that suppose we denote amount in the second envelope from the beginning as that A, and repeat that derivation and obtain 25% of increase in the first envelope. So by some content of this simple consideration of the situation, there is no sense to change envelopes. But anyway, here is a derivation of 25% profit. So it raises a question to switch or not to switch. And this problem amazingly was studied in different areas of human interests. And it was considered from probability point of view, decision-making, Bayesian estimations, game theory, mathematical economics, logic. And as I mentioned, there are so many works on this problem. And here are several examples. First, this problem was formulated in 1953 in the work by Krejcik. And from that time, I simply put here several examples. It was considered in professional journals in physics, like that, fluctuations, synthesis, its logic, epistemology, or analysis, mostly logistical analysis problem, and many other works, as you can see here, those several examples. And it continues to be considered till now, you can see by some recent references here. So how we can look at it from what we know from the area of analytic hierarchy process, and maybe to find a feasible solution, let's say, if not actually solving this problem, and that's all. It seems that we can do it if we consider not linear, but some nonlinear utility function used in analytic hierarchy process. and even not one function, but a couple of them at least.
Dr. Lipovetsky, sorry for the interruption. You have 3 more minutes.
Oh, really? Okay, thank you.
Yes.
Amazing. Okay, here are a couple of those scales. And why from a knowledge hierarchy? Because we have ratio scale in a knowledge hierarchy. If some pair comparison for a couple of items is k, opposite is 1 over k, and we have all the known features considered in a knowledge hierarchy environment. So what's suggested here? There were such works as some robust estimation in HP and Markov steady state probabilities in HP, which I made with co-author Mike Conklin. So it's possible to transform original ratio scale in an analytic hierarchy to so-called shares scale, as it's shown in these formulas, with features that we always have values from 1 to -1 and skew-symmetric matrix, deviations from mean level opposite and equal. So in this scale, expectation for those two options for envelope is actually 0. Similarly, deviations are zeros, but expectation is here in formula 7. It's 1/2. So it's the same for one envelope or another. Similar results are for logarithmic scales. So both those scales make some nonlinear scaling for original values from HP, but it shows what we can obtain in a logarithmic scale, for instance, or those share scales. Utility on those are opposite, and we have 0 expectation. In our original scales, it means that we should take utility not as mean arithmetical, but mean geometric. Then we have the same value as in the first chosen envelope, and there is no need, no meaning to substitute one with another. So that paradox is solved. Here are simply some showing how those scales behave. They are very similar, logarithm and shares, practically undistinguishable. They can be transformed one to other. They are very similar by I. You can see it. So what we can say in conclusion, that this two-envelope paradox can actually be dissolved. It does not exist in these scales. So why it is important? Because it shows that some problems we should decide not in our, let's say, more habitual human arithmetical kind of arising, but in some more specially chosen scales. Well, I believe I can finish on it. So thank you very much. I'm on time.
Excellent. Thank you, Dr. Lipovetsky. I think it was really interesting. And we should have time for 1 or 2 questions if we have any.
I can add some other paradoxes could be considered from similar mainframe. So maybe it could be used much more widely.
That could be interesting to see how it applies in different paradoxes, right?
Right.
Yeah, I think so.